Good evening, children. Welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Welcome to today's class. Yeah. So today let us finish some problems based on the modulus and absolute values, and let us go to the binary system today. Okay. Yeah. So we stopped the exercise 9 problems are already completed. Let us go to the 10th one. Now we need to find the number of zeros at the end of 6 square minus 1 factorial, right? This one we discussed, right? Yeah. Now if x value is equals to minus 7.54, x value is minus 7.54 is given, and then we need to find out fractional part of greatest integer of x. Then we need to find out fractional part of greatest integer of x. Okay. So let us find the greatest integer of x first. So greatest integer of x. So usually we know that minus 7.54 is lies between minus 7 and minus 8. Minus 7 and minus 8. That means the greatest integer value always chooses the least number, right? So we have to go through the minus 8. That means the value which is lies between minus 7 and minus 8, then its greatest integer is minus 8, because minus 8 is smaller than 7. So the greatest integer value always chooses the smaller one, right? Yeah. So greatest integer fraction of this is minus 8. Now let us find fractional part of x. Fractional part of greatest integer of x. So fractional part of greatest integer of x equals to, greatest integer of x is minus 8 and its fractional part becomes 0, because there is no fractional part, it is exactly an integer, there is no fractional part, so the value is 0. In your options it is given that cos 90 degrees is our respective value. Cos 90 degrees value is 0. So you will learn in trigonometric topic what are the trigonometric ratios and their values also. So there we will discuss about this. So according to your options, you need to choose cos 90 degrees. Okay? Yeah. Right. Next. So if x equals to minus 3.4, x equals to minus 3.4 and x equals to minus 3.4, we need to find that absolute value of x into fractional part of x plus x into greatest integer of x. Okay. Now let us identify the absolute value, greatest integer value, then last we need to find the fractional part of x. Okay. So what is absolute value? Whenever the x value is a positive integer or negative integer, it always gives its positive. So from this we can take that modulus of minus 3.4 becomes 3.4. Okay. Now greatest integer of x. Greatest integer of x is always chooses the smaller number. Now here minus 3.4 is lies between minus 3 and minus 4. Among them smaller number is minus 4. So therefore the greatest integer function is minus 4. Next, fractional part of x. Fractional part of x, it is nothing but x minus greatest integer of x. So x value is minus 3.4 minus greatest integer of x is nothing but minus 4. So minus or minus become plus. So it is minus 3.4 plus 4. That means 4 minus 3.4 is nothing but 0.6 plus 0.6. Now let us substitute in this and identify the required value. Now modulus of x is 3.4 into fractional part of x is 0.6 plus x value is minus 3.4 and greatest integer of x is minus 4. Now let us see this. 6 4s 24, 6 3s 18, so 20. So this is 20.04 will be the multiplication of or product of 3.4 and 0.6. Okay. Now here minus into minus become plus. 3.4 into 4, 4, 4, 16, 1 here 13. So 13.6, add both of them, you will get the answer is 15.64. So 2.04 plus 13.6 is nothing but 15.64 will be the value of the absolute value into its fractional part. Okay. Right. So let us go to the next. So next problem, what is the interval between minus 1 is less than x less than or equals to 1. So it is given that minus 1 is less than x less than or equals to 1. So simply the x value is lies between minus 1 and 1. Sometimes it can be equals to 1 also. So whenever you have the equal to symbol, we need to use square bracket or else open brackets we are using. So this is minus 1 to 1. So left open and right closed. The value of x belongs to minus 1 to 1. Okay. So that is the one of the value. Next. So let us find out the modulus of x minus 2 is greater than x. Modulus of x minus 2 is greater than 6. So we have discussed the conditions of modulus value for inequalities. Whenever modulus of x is less than a, then the solution of x is lies between minus a and plus a. This is first condition. If modulus of x is greater than a, then x value is less than minus a or x value is greater than a. That means whenever you have seen that less than symbol, the x value will be between the roots minus a and plus a. But here the x value is not between the roots. That means it can be less than the negative value or more than the positive value. We need to consider like that. Okay? Yeah. So according to this condition, it is greater than 6. Greater than 6 means what we have to take? So both we should apply. That means x minus 2 is less than minus 6 or x minus 2 is greater than 6. That means this minus 2 is transposed that side, becomes plus 2. So minus 6 plus 2 becomes minus 4. So x value is less than minus 4. Now here x value is greater than 8. So according to that, if minus 4 and 6 8 are the roots, x is less than minus 4 and greater than 8. So any one of the value. Less than minus 4 means we don't know exactly. It can be minus infinity until we can take it. The absolute value will be satisfied. So that means x is belongs to minus infinity to minus 4 union 8 to infinity. This is the solution of the absolute value of x minus 2. Okay? Yeah. So we'll go to the next question. So let us see the next one. So modulus of 8 minus x by 4 is less than or equals to 4. So whenever you have seen the modulus absolute value in inequality form of less than, we need to take that x value is lies between minus 4 and plus 4. So here x means the entire fractional part. This completely we have to considering as a x. It is lies between minus 4 to 4. It is given already r equals to symbol. We should carry the same r equals to here also. So 8 minus x by 4 less than or equals to 4. Now I am going to multiply these three terms with all together. I multiply with 4. That means to remove this divided by 4, I am going to multiply here. So that is minus 4 into 4 less than or equals to 8 minus x less than or equals to 4. Because if I multiply with here 4, numerator 4, denominator 4 will be cancelled. Okay? Yeah. Here also I need to multiply 4 into 4. So that is nothing but minus 16 less than or equals to 8 minus x less than or equals to plus 16. But we want only x here, but we have 8 minus x. Let us remove plus 8. For removing the plus 8, we need to add minus 8, right? So minus 16 minus 8, so less than or equals to 8 minus x minus 8 less than or equals to 16 minus 8. So that means minus 16 minus 8 is nothing but minus 24 is less than or equal to plus 8 minus 8 cancel. Here minus x is less than or equals to 8. But we want a positive x, so multiply entire symbol with negative symbol, then the less than symbols will become the greater than. That means 24 greater than or equals to x greater than or equals to minus 8. So from this we can write minus 8 less than or equals to x less than or equals to 24. That means x value is less than minus 8, and that means it is lies between minus 8 and 24. Sometimes it can be equal also. That means we should use closed brackets. It indicates the values of minus 8 and minus 24 also, sorry, minus 8 and 24 also include in the solution. That is minus 8 to 24. Close both sides. Okay. So this is the solution for this. Now let us go to the next problem. That is 17th one. Yeah, greatest integer of 2.4, sorry, fractional part of 2.4 plus fractional part of minus 1.6 plus fractional part of 3.2. So we need to identify this value. For positive values, directly we can recognize the fractional part of it. It is 0.4. That means 2.4. So remove the whole number. We will have the 0.4 here. And this is also 0.2. But whenever you have seen the negative symbols, let us identify through the formula fractional part of x equals to x minus greatest integer of x. Now what is greatest integer of x? Greatest integer of minus 1.6. Minus 1.6 is lies between minus 1 and minus 2. Among them, smallest number is minus 2. So therefore greatest integer of minus 1.6 becomes minus 2. Okay. Now let us find here. Fractional part of minus 1.6 is equals to x. X is nothing but minus 1.6 minus fractional part of x is minus 2. So becomes plus 2, nothing but 0.4. So this value becomes 0.4. Just add all of them. It is 1.0. 1.0 is nothing but 1. Therefore the required value is 1. Okay. Yeah. So let us see the next one. Number of zeros at the end of 6250. Number of zeros at the end of 6250 factorial. So we already learned that number of zeros, that is nothing but number of zeros for n factorial is nothing but n by 5, greatest integer of n by 5 plus greatest integer of n by 5 square plus greatest integer of n by 5 cube plus and so on like this. Now in the place of n, we can identify the number 6250. So let us substitute in the formula 6250 by 5. It is in the square greatest integer function plus greatest integer of 6250 by 5 square. 5 square value is 25 only. Next 6250 by 5 cube. 5 cube means 5 into 5 into 5, 125, and 6250 by 5 power 4. 5 power 4 means 625, and 5 power 5 also possible because 625 into 5 nearly 3000. That is 625 into 5, 5 has 25, 2, 12, 1. So this is 3120. With another 5 will be more than 15,000. So last number is 5 power 5. So remaining all if you take, that is 0 point something will be according to the greatest integer function. We need to choose the smaller value. So 0 point something means lies between 0 and 1. So obviously smaller value becomes 0. That means after 5 power 4, all the values becomes zeros. So we can check up to 5 power 5. That's enough. Okay. Na? Now 5 table here, 625 is 125 times. 5 into 125 is 625 with 0 also. Okay now? Next, 25 table, 25 25s are 625, so 250 times. 5 cube value 125 here 5 times, nothing but 50 times. 5 power 4, 5 power 4 means 625 exactly 10 times. So this is 5 power 5, 3000 something, nearly 2 times. Yeah, exactly 2 times, not nearly, it is exactly 2 times. So add all of them. So 250, 300, 312. So add the 312 here, you will get the answer 1562. That means while you are multiplying 6255, that means nothing but multiply first 6250 natural numbers, you will get 1562 zeros at the end of this number. Okay. So this answer is, our required answer is 1562. Check. Yeah, let us take that next question. So here x value is 9.3. X value is 9.3 and we need to identify the greatest integer of x into x and fractional part of x into x as well as greatest integer of x into x. Okay, anyone is same now? Let us find out greatest integer of x into x. So x into x is nothing but 9.3 into 9.3, 93 93s. So let us see, 14 means 20 is 86, 3 3s are 909, sorry 49. That means here 7 less, 14 less, overall 86. So 8649, while you are observing that it is 86.49, 86.49 is nothing but 86. Okay, na? Fractional part of this, so fractional part is 0.3. X into x value see 86.09, so its fractional part 0.49. Okay. Yeah. Now let us see this value again 86. Now our question is least integer function of greatest integer of x into x into or plus it is given, yeah, comma fractional part of x comma x plus greatest integer of x into x. Okay, but here it is given into, no, so we need to multiply 86 into 0.49. So let us find out the number with 49 first. So 9 6 are 54, 5 9 5 9 8 72, 77, 4 6 are 24, 2 32, 34. So 11, 12. That means 42.14. 42.14 plus this value is 86.49, so greater than, yeah, it is 86. So let us identify both of them, add both of them. 86 plus 42.14, it is, yeah, 128.14. Its least integer function will be 129. Its least integer function will be 129. So let us find this. Next question, that is, so fractional part of 1.4 plus fractional part of minus 0.6, fractional part of 2.6 plus fractional part of minus 1.4, and it is 3.2 as well as minus 2.8. Okay, so whenever you have the fractional part of negative integers or negative decimal numbers, we'll do one thing, that decimal value where subtract from 1, we'll get the positive value without doing again x minus greater than 0 function, x formulas and all. So directly we subtract from 1. Okay, so here fractional part is 0.4. If you remove whole number 1, so still 0.4 will be remains. Here it is negative now, so 1 minus 0.6. 1 minus 0.6 is 0.5. Now 2.6, fractional part is 0.6. Here also minus 1.5. That means let us subtract from 1, it is 0.6. That means only decimal value subtract from 1. 1 minus 0.4 is nothing but 0.6. Now here fractional part is 0.2 and last one also 0.2 because negative no. So 1 minus 0.8 becomes 0.2. Add all of them. So these two becomes 1. 0.4, 0.6 value 1, 1 plus 1, 2, 2.4. 0.2, 0.2 is nothing but 0.4 while you're adding 2 plus 0.4, 2.4. That is the answer. Now let us go to the next problem. Yeah, it is 31 factorial is divided by 2 power n, then the n value is 33 factorial is divided by 2 power n. And we need to find the n. What is n here? N value will be the highest power. Am I right? So how to find the highest power? It is a prime number or not? 2 is a prime number. So first the greatest integer of 33 by 2 plus greatest integer of 33 by 2 square plus greatest integer of 33 by 2 cube and greatest integer of 33 by 2 power 4. 2 power 4 value 16, and let us take the greatest integer of 2 power 5. So 2 power 5 is 32. If you take one more 2 power, that one more 2, it will be 64. So we need to take up to 2 power 5. So 2 table here, 16 point something will be. Okay, so 16 greatest integer function region. Here 4 table, 4 8s are 32 point something. 8 means 8 point something, so 8. Now 2 cube value 8, 8 table 33 4 times, that means 4 point something, greatest integer of 4 point will be 4. Now 16 here 2 times and 2 power 1 is 1 time, 2 power 5 is 1 time. Add all of them here, 20, 20 plus 10, 30, 30 plus 1, 31. Therefore, when you divide 33 factorial by 2 power n, the highest power n will be 31. Okay. Let us go to the next question. Yeah, here observe that the exponent of 6 in 50 factorial, exponent of 6 in 50 factorial, exponent of 6 in the sense of highest power of 6. Highest power of 6 means we should use the same formula how we did the problem here, second one. But here the condition while we are discussing about highest power of a prime number we are taking. Highest power of prime number. But 6 is not a prime number, 6 is a composite number. Now I am going to write 6 is product of 2 into 3. Because every composite number can be expressed as product of primes. Now let me find out with 2 and with 5 separately, then I'll identify. Yeah, 50 by 2, greatest integer of, next 2 square, 50 by 2 square and 50 by 2 cube value 8, next 16, 16 after 32, 32 after 64, 64 is more than 50, we can stop up to 2 power 5. Now 2 value here 25 times after cancellation, here 4 table in 50 12 times, 12 4s 48, 12 point something, so according to the greatest integer function 12 point is nothing but it reaches 12. Now 2 cube value 8, 8 table 8 6 are 48. Whole number we can take, decimals we can neglect. So 16 table 16 3 is 48 and 32, 32 to 64 will be 1. Now add all of them. This will be 10 up to here, 6 plus 3 plus 1, 10. 10 plus 25, 35, 35 plus 12, 47. So highest power in 50 factorial is 47. It is according to 2. But still we need to identify 3. Now for 3, highest power of 3 we need to identify. So greatest integer of 50 by 3 plus 50 by 3 square value is 9. 50 by 3 cube value 27. 50 by 3 power 4 value 81. 81 we can neglect because it is more than 50. The answer will be 0 point something. According to greatest integer function, it reaches 0. So we can neglect there onwards. So let us see that these 3 terms. 3 table, 3 ones and 20 means 3 6 are 18. 18 point something. According to greatest integer function, it reaches 16. Sorry, 16 point something. 9 table, 9 5s 45. 27 2s 54 only one time. 16 plus 6 is 32. Now among them, smaller one is 32. Therefore, it will reach 6 power 32 in 50 factorial. Factor we should check. Okay, no? Sorry, actually it is 22. So let us go to the last problem, square root of. It is looking like somewhat different. So square root of 1. This square root of 1 is kept in greatest integer function plus square root of 2, 3, 4, 5, 6. Up to 6 it is given. So square root of 2 and greatest integer of square root of 3. Greatest integer of square root of 4 is given or not? 4, 5, 6. 4 also given. And greatest integer of root 5. Greatest integer of root 6. So root 1 is equals to 1. So greatest integer of 1 is 1 itself. Root 2 value nearly 1.414 and so on. That means root 2 is an irrational number, non-terminating decimal. So 1.414 and so on, it will go like that. So approximately greatest integer function value is 1. Because 1.414 lies between 1 and 2. So according to greatest integer value, we need to choose 1. So that's why this value 1. Root 3, what is the root 3 value? Root 3 is nearly 1.732. It is also lies between 1 and 2. So its greatest integer function is 1. Root 4 value exactly 2. So greatest integer function of root 2 is 2. Root 5 is 2 point something, it reaches 2. Root 6 also 2 point something, it reaches 2. Because to get 3, we should get root 9. Root 9 value 3. Until then, all are lies between 2 and 3 only. Now, 3 2s are 6. 6 plus 3, 9. The required answer is 9. Okay, now? So please check it. Digital number system, we need to discuss how to convert it into binary system, octal system. Okay, so we'll discuss that system in next period. That's it. So thank you one and all. Have a nice day.